Hello and welcome to Mr. Ridley's Product Design, and this is an A2 revision clip and we'll be looking at types of metals. By the end of this clip you should be able to describe ferrous and non-ferrous metals. You should be able to explain the properties of these metals, and more importantly you should be able to answer exam questions relating to types of metals and analyse products made from these materials. So, metals in product design. Metals have always been important in making products. These weapons and tools are from the Iron Age. The fact that the Bronze Age and the Iron Age were named after metals shows their importance in making products and artifacts. This iron bridge in Shropshire was built in 1778. It was the first bridge in the world to be made from metal. Some people consider the building of this bridge to be the starting point of the Industrial Revolution. During the Industrial Revolution, engineers used metals to create bigger and stronger products. This engineer, Isambard Kingdom Brunel, built this ship, the SS Great Britain, in 1845. At this time, it was the biggest ship in the world, made from iron. As technology moved on, engineers discovered that by adding carbon to iron, it made steel. Steel is stronger and harder than pure iron, and moved forward for other engineering and manufacturing products. In the current day, the demands of advanced technology and other metals such as titanium and magnesium are added to make alloys. Inside this jet engine, the metal parts are heated to temperatures as high as 2000 degrees C. Steel would melt and the product couldn't be made. So modern engineering products such as this jet engine could not be manufactured without alloys and materials like titanium. Where do metals come from? Metals are naturally occurring in the earth in the form of metal ore. Metal ore is mined, washed, treated and then heated in a furnace. The pure metal ore is run off. This process is known as smelting, and this for steel is done in a blast furnace. Iron ore is the basis for most steels. Ferrous and non-ferrous metals. If the metal is iron or contains iron, then it is a ferrous metal. All other metals are non-ferrous. So we've got ferrous metals here are steel, stainless steel, cast iron. Non-ferrous metals, aluminium, copper, brass. You should know these. Ferrous metals all contain iron and they are usually magnetic. Most ferrous metals will also oxidize when exposed to air and moisture. So we're going to look at some metals now. Firstly, we're going to start off with this ferrous metal, mild steel. It's cheap. It's the most common metal used in manufacturing products. It's tough. It can take knocks without damage. It is malleable. That means it can be cold pressed into shape without breaking, making panels, for car panels. It is magnetic and it is easily and widely recycled, but it will rust if exposed to oxygen or to the atmosphere. Another ferrous metal, stainless steel. This is a tough material. It is malleable, so it's shaped into things like the sink. It is easily cleaned and it can be recycled. Specialist equipment is needed for cutting and welding because it is a hard metal. This metal, high carbon steel. High carbon steel is used to make tools and drills. It generally needs to be heat treated. It is very hard, so resists abrasion, so it is good for drilling other materials. But again, it will rust if not protected. This ferrous metal is cast iron. Cast iron is strong in compression. It is strong, but is brittle and will crack if hit or has impact, so it's very susceptible to impact. It is resistant to rusting and it can easily be cast into ornate shapes. So the fireplace here is cast iron. Wrought iron. Wrought iron is tough and will resist impact. It is ductile and can be hammered and shaped easily, and it is resistant to rusting. We're going to look at some non-ferrous metals now. These metals do not contain iron and they are not magnetic. Aluminium. Aluminium is lightweight. ductile, which means it's easily drawn into thin wires or formed into shape. It's malleable. It's also easily cast, and it is a good conductor of electricity. It has good corrosion resistance once an initial corrosion oxide coat is formed. It is relatively expensive compared to mild steel, but it is easily and widely recycled. Copper. Copper is malleable. It is ductile, made into wire easily. It is a very good conductor. It has good corrosion resistance, and it can be recycled. But again, it is more expensive than aluminium or mild steel. It does tarnish and change colour over time, but it doesn't corrode readily. Zinc is mainly used in a coating which is called galvanizing. Zinc is extremely resistant to corrosion. It is a good protective coating for railings and dustbins, I can see here. It is brittle but easily cracks on its own, and it can be recycled. Brass. Brass is very resistant to corrosion. It has good fluidity, which means it's easily cast into difficult shapes. It is a good conductor of electricity, and it could be highly polished to a good finish. Again, relatively expensive compared to the cheaper materials. Titanium. Titanium is as strong as steel but less dense. It is also extremely resistant to corrosion, and it is very hard and resistant to wear. I've been talking about some of the properties of metals, and these are important that you know these. Ductility or ductile is the ability of a material to deform, usually by stretching along its length. So copper is ductile, and it can be shaped into wire or pulled into wire. Malleability, this is the ability of a material to permanently deform. So to be able to be press formed is malleability. Hard is the ability of a material to resist wear, scratching and indentation. Toughness is the characteristic that the material does not break or shatter when receiving a blow or under sun shock. And conductivity, of course, is the conductivity of electricity and heat. It is important to be aware of these abilities when you're answering exam questions for A2. There are also the strength of metals. Some metals have different strengths. So there is tension. Tension is the ability to withstand being pulled apart. Compression is the ability to withstand being squashed or crushed. And shear is the ability to withstand being broken apart. Different metals have different features of strength or characteristics. So for example, cast iron is very strong in compression but not in shear. So it is used for pillars, structural pillars in buildings where it is just in compression. An alloy, metals and alloys. An alloy is a mixture of two elements where at least one of these is a metal. So for example, brass is an alloy of copper and zinc. Obviously to be an alloy, one of the elements have to be metals. This picture of the periodic table shows which elements are metals. So the elements here are metals, and these are all what we call pure metals. Metals that do not appear on the periodic table are alloys. These are made when pure metals or other substances are combined to form a different metal. So, element, gold, copper, aluminium, silver, iron. Alloys, brass, stainless steel, mild steel. Why are alloys so important? Because, as we said already, alloys have properties that are superior to the base metals. So as we talked about earlier on, the jet engine really needs alloys to function. It would not be able to function. You would not be able to make certain products now without alloys. Brass is formed from copper and zinc, and it is much harder and less resistant to wear and corrosion than both copper and zinc. Why is this? Because alloys contain atoms of different sizes, which distorts the regular arrangement of atoms in the metal. This makes it more difficult for the layers to slide over each other, so alloys are often harder than the pure metal, or stronger. Now, it's time for questions. Metals. Which ferrous metal is resistant to rust and staining, able to be formed by pressing, tough and resists wear? It's stainless steel. Here's an AS type question. This watch is made from titanium. Explain why this is a suitable material for this product, and what benefits does its use give the user of the watch. So we've got a titanium watch there. Why is it a suitable material? What benefits does it give the user? Titanium is extremely corrosion resistant. A. B. The watch can be used in any environment and will not corrode or tarnish. Titanium is lightweight. A. B. The watch will be lighter and more comfortable to wear. A. Titanium is very hard. B. The watch can be polished, and this will keep the polished finish well. So there's an exam type question. Which of these is a pure metal and which is an alloy? Gold is a pure metal. Brass, alloy. Copper, pure metal. Pewter, alloy. Stainless steel is an alloy. Steel is an alloy of iron. Mild steel is still an alloy. Aluminium is a pure metal. Silver, pure metal. Iron is a pure metal. Which alloy is a mixture of zinc and copper? The alloy is brass. Metals, non-ferrous metal. Which non-ferrous metal is a very good conductor? Ductile, able to be pulled into wire and has good corrosion resistance. Copper. Which ferrous metal is used to make tools and drills? Is hard and resists abrasion and can be brittle if not heat treated correctly. It is high carbon steel. Here's another exam type question. This sink is made from stainless steel. A. Explain why it is a suitable material for this product, and explain what benefits does its use give the user of the product. A. Stainless steel is malleable. So this allows the metal to be easily press formed into the shape of the sink. A. Stainless steel is tough, which means the sink will resist impacts, knocks. And stainless steel is resistant to corrosion and chemicals, which mean the sink will not become discoloured or tarnished through use. Okay, that's it. Thanks for watching Mr. Ridley's product design, and good luck in the exam.